Hey, what's going on, guys? Kamegi here. Last video we've ended up with absolute X and absolute Y addressing for STA instruction, and I said that I'll implement indirect X and indirect Y without covering that in a not doing that live at very least. So I did that and just promised to show how that works. So yeah, let's have a look how those addressing modes work, and then we'll start implementing STX and STY registers. STX and STY instructions to store the data to the memory from the X and the Y register respectively. Okay, so this test 6 and 7, yeah, so I just break the memory comparison somewhere over in here, for instance, just to make it print in the previous. Okay, so we have that. So don't look at this memory file. That's because I've altered the value just to make the program show this part of the test. So we have the instruction is currently STA, and we have 0 page address and X offset. So this is known as indexed indirect addressing mode. So the opcode for this is 81, and 20 is the value of where are we gonna be looking for the 0 page address. We're gonna be looking for an indirect address, right? But you might be wondering that it would be here, but nope. It's available at 0, 1, 2, 3, 4. So actually 0 page 24, not 20. So how do we get this? How do we get this offset? So we get this offset from the X register. So we're getting the value of 20, which is the 0 page address of where to look for this indirect address, right? Then we're adding 4 to this value, right? So we have 24. Now at 24, we're looking for an address that we're supposed to be writing data to. So 7410, it's the little endian byte order. In the big endian byte order, it would be 1074 respectively. Okay. So yeah, I'm just wondering. Just hold on a second, guys. I want to check one thing quickly. Yeah, I was using for absolute addressing. Before I was using just a bit different values, but that's okay. Yeah. Okay, yeah, that's okay. That's all right. So the address of 1074 in the that's the absolute address in the simulated 6502 memory, the memory for 6502 processor. Okay, so and we're gonna take this value and write the whatever we have in the A register to this address, but not directly, but indirectly instead. So here we don't have this 7410, right? We have this 20. So we're looking for a 0 page, adding the offset of 4 from the X register, getting this absolute value, and then we're going to be writing to this absolute value. So this is the state of memory before we've executed the instruction, and after we've executed the instruction, we have this value of 21, which was the value of A, that we've stored at the address 1074, right? So using the X just to adjust this 0 page address. So that's the reason why it's called indexed indirect. So first we index, and then we go in for this indirect address, right? So the program counter gets increased by 2. So D, E, F, 2 bytes only. So 2 bytes. The value of the registers are not getting changed. So I will now restore this this test case. So if I just say like this, right? Yeah, and now I can run again. So now we're coming to the territory of, well, it's not seen yet, so I can probably, if I just don't print this stuff at the end, I think there should be enough space. Yeah, so here we have the indirect index addressing, and this one is a little bit different. Okay, so the opcode is 91 and 24 is now the address at the 0 page where we're looking for the absolute address. So everything just like it was in the previous example, but here is the difference. So instead of adding the offset from X, we just directly go to this 0 page 24. There we fetch this 1074 value, which is the absolute address, right? And before we have written anything, we had this 21 from the previous example, right? But now we have in the Y register, we have the value of 2. So this gets added to the address of 1074. So 1074 plus 2 in Y register would be 1076. And at the address of 1076, we store the value of the A register, which is 32, right? So this is pretty much all about it, right? And let me just restore this. Okay, value, right? So yeah, so program counter gets increased by 2, right? So F 10 11, F 10 11, yeah, increased by 2, and 32 in the A register. Yeah, so the processor state didn't change apart from the program counter, right? And in the memory we've just written this 32. And fortunately, we have indexed indirect and indirect indexed addressing modes for only for STA instruction. So if I didn't miss anything, then we won't really need to have this anywhere else in the source code, in the instruction set, right? So what we're going to be working on in this video are the STX and STY, so store X register to memory and store Y register to memory. And we're going to be reusing the code from what we already have for STA. So this is going to be really simple, I hope, right? But before anything else, I just want to dump this tests for STA to my unit test, where I just dump everything. So let's take the header, copy and paste, and here we'll have the STA, right? Store and starting from here, so from test 1. Well, actually, I could have saved them partially, but I don't really want doing that because, yeah, I would rather be grabbing test by test, altering, so not to miss anything, right? And also Control X, okay. If I find some inaccuracies in the commentaries, I would be able to fix them as well. Okay, so yeah. So now we want to say STX and the 0 page addressing mode. So it's the same as STA 0 page addressing mode, apart from it actually stores the value of X register to the 0 page, not the value of the A register. So I'm just thinking, what can I grab from here? So here I actually need to initialize the value to, yeah, okay, let's grab the entire test here, copy, and just bring this in. So yeah, let's command out up to the execute. Yeah, for now just up to the execute, so don't want to execute anything for now. So okay, so we'll now need to change the instruction, and also hold on a sec, also we need to load the value not to the A register, but to the X register. So let's get started. So to the X register, I want to load the value of hexadecimal 45. Okay. Then I need to adjust the opcode. So STX 0 page is 86. So remember this, 86. 86. 86, like this. And this is gonna be STX to 04, to 0 page 4, which is okay. So yeah, 45 in X register, 8604, which is correct. Then yeah, so let's go and implement this. So I just call the execute now and go into execute. All right. So yeah, here we have the STA, right? So here I can simply say compare whatever in AL. So AL holds the opcode, and the instruction STX to 0 pages. So is this STX 0 page address and opcode? If so, then jump equals to STX ZP. So STX ZP, we don't yet have that. Actually. So if so, then execute it. All right. So now we need to implement this STX 0 page. So I will go to STA 0 page. So STA 0 page, and just right below, actually maybe not even below here, but maybe I should do this. So I was doing this after LDA 0 page. So yeah, maybe I can do this after LDX 0 page. So just grab, yeah, I've lost the order a long time ago, so it doesn't matter that much really. So this is gonna be the STX 0 page address and mode, STX, and here everything should be the same apart from the fact that we are loading the value of X register to get stored to the memory. And now in a test 001, so now we want to execute, and after execution print the register state. That should be the same. We can actually not do that, but yeah, let's keep that actually. So print the memory range, and now we should get the value of whatever we have in X. We have this value of 45 in the X register, and we store this. STX results in storing the 45 to 0 page 0, 1, 2, 3, 4. So 0, so the 4 address of 4 in 0 pages. Okay, it gets the value of 45, which seems to be okay. So only adjusted the program counter, nothing else. So yeah, let's adjust the test cases for this sort of a thing. Well, actually, I believe that the test case should be exactly the same, because we are referencing the same. Yeah, we are referencing the same memory address. So yeah, we're not referencing the registers, and like the output looks exactly the same as it was in the previous example. Well, we could have used another value here and then adjust the test case, but I can't see any particular reason for doing that actually. So we can keep it just as is. Okay, so we're done with 0 page STX to 0, so STX instruction storing the value from the X register to the 0 page. And now the next one is gonna be, well, actually I could have made the same for STY currently, but no. Let's actually go step by step. So only 3 instructions, not really that much. So 0 page plus the Y offset. 0 page plus the Y offset. Okay, 0 page plus the Y offset. I had this in LDY, right? But yeah, I would rather be altering the existing one. So 0 page. So what can I use for this? Just wondering what test case. Okay, hold on a sec. Here I had the test 2. What was the second test for? No, it's the first test for STA. What was the second test? Okay, this was like so. So I can probably rely on this test case. Okay. Copy and right. So, but I need the offset in the Y register, right? So here to register X, we load the value to store. To register Y, we load the offset. And now we need to adjust, this. Yeah, just comment out only the test case in this case. All right, and 96. I have the 96 opcode. So remember 96. 96 here. And don't execute for now. Okay, so what we got 9604. Okay, and in Y we have 1, so here we should get the value. Here we should get the value of whatever we have in X, so 38 should get here. Okay, now let's go and implement this. So execute. And here compare AL with STX 0 page plus Y offset, STX 0 page plus Y offset opcode, and if it is, then jump equals to STX 0 page Y. I just want to make sure that when I did say, yeah, LDX 0 page Y, now STX 0 page Y. Yeah, this should be just it. STX 0 page Y. So what am I? The one I'm going to be reusing is actually STX 0 page. So STX 0 page. So I'm going to be reusing this code, and I'll just alter the offset. So copy this one, and now I want to find the LDX 0 page Y. Yeah, and I bring this code here. Okay. STX 0 page Y, STX 0 page plus Y offset addressing mode. Okay. So at the current state, it should just override the value of what we have previously, value of 45, I guess, with the newly created value of 38. Yeah, but that's because we didn't yet add the offset. So just need to find, so here, all right, so we have this edit to memory. So here I believe we can simply say hold on a second, guys. I just want to use exactly the same register I have been using. So for instance, if I just search for STA 0 page and X, yeah, I would rather actually reuse this one because it already contains all I need. And STX 0 page Y. So actually, yeah, it's just easier to reuse. I just want to have the same registers being used. So in this case, I'm using, yeah, I'm still using BX, by the way. Yeah, that's cool. But here, I want to store the value from the X register, right? And the offset, I want to take the offset from the Y register. Now this should be working in theory. And let's see how it works in practice. And it does. Okay, so 0 page 04, 0, 1, 2, 3, 4, plus 1 stored in Y register, and we write the value of X register there. So STX 0 page plus Y offset. Okay, this seems to be so far so good. Seems to be okay. Is it? Is it really? Yeah, it should be. Should be just fine. So let's adjust the test cases. So test 002. And yeah, the test cases, by the way, should be working out of the box because we didn't really change the values. So make sure that instruction, so no, this is not STA, this is STX, and not X but Y. Okay, yeah, should be the case. So let's have a look. Yeah, it seems like passing the tests, which is okay. So 38, program counter increased by 2 because 2 bytes just to encode this instruction. Okay. Yeah, this seems to be like this is kind of it. All right, so now let's go to the next instruction, and the next instruction is STX absolute, and that's pretty much all about it. So just the absolute one. Okay, this is cool. This is really cool. So just the absolute. I just need to find the STA absolute and change the register, and we are done. So go into the tests. Yeah, it's in like this one. Okay, so I can grab the entire test here. Grab the entire test and bring it in. Okay. Save. So this is gonna be STX and sorry guys, I've been distracted a little bit. So where did we stop? Yeah, it prints the value of A to 45. So in the no, not the A register. So this should be in the X register. That's the first thing. Then they will change the opcode. So STX to okay. Now let's grab the opcode and uh 8E 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 okay. Yeah, let's get rid of the verification for now. Okay, so 8E0401, this is the little endian order. The absolute address is 0104. Here we're supposed to have the value from the X register. So 45 is about to go here. 001, 2, 3, 4. So it's gonna be here. Okay. Yeah, I'm just wondering, why does it still execute? This is a bit strange. Oh no, it doesn't execute. It actually says that the 8E is not supported, which is good, by the way, which is good. So even this part works properly. So yeah. So here. Compare AL with STX absolute. So is this the STX absolute address and opcode, and jump equals to STX ABS absolute. Okay. Okay, so where would I grab the STX ABS template from? Probably from STA ABS. So STA ABS. Yeah, that's a pretty nice one. So I grab it from here. And where do I put this? It goes after LDY ABS. This is a bit strange. Oh, and here I just, yeah, the order is the order is completely being smashed now. Yeah, that's a little bit unfortunate. Yeah, for instance, I have STA. Oh no, it's not. So I have the STA ABS X after, oh, all the absolute. And what about the 0 pages? Yeah, this is unfortunate, really, but well, the order doesn't really matter that much. But so let's have a look. So we have LDA, LDX, LDY. Okay. Then we have LDA 0 page. Now we have STA 0 page. And now we have LDX, STX 0 page. After, yeah, I think I got the point. Okay, I think I just got the point. Yes, it should be a little bit different. Sorry guys, you don't really need to care about this. The order of this instructions doesn't change anything. Well, I hope so, to the list. So yeah, on the other hand, I could have put this to maybe just this one is in the wrong place. I just did put this STA absolute after all the absolutes, not only after LDA absolute. on the other hand, I don't really want to change anything because it's working currently, and who cares about the order? So STA 0 page goes after LDA 0 page. Okay, so this is correct in regards to the order that I currently have. STA 0 page X goes after LDA 0 page X. And in this case, STA absolute should go after LDA absolute. So just need to be, so this one needs to be put here. So maybe, yeah, maybe I just fix this first. Control X. Control W. Now it's not going to be working because I didn't yet paste the one for STX ABS. Okay. And now STA 0 page X. Okay, STA 0 page and STX 0 page goes after LDX 0 page. Okay. So STA absolute, which now goes after LDA absolute, and STX absolute should go after LDX absolute, right? At least according to my weird order of instructions. So this is going to be STX absolute, STX absolute, from the register X, storing data to the memory. Yeah, let's have a look. Oh, I've closed the terminal for some reason. Okay, so we have the value of 45 being stored from the X register using this instruction to the absolute address of 0104. Yeah, which seems to be okay. Yeah, I'm sorry for messing up with this with the instruction order again. Like, it doesn't really have to kind of like affect anything in my dreams at very least. So yeah, okay, let's now adjust the test cases, and they probably should be working out of the box. Apart from the program counter, everything else should be working. Oh, even the program counter works. So 4 and then add in 3 bytes, 1 2 3 4 5 6 7. All right. Okay, so yeah, even the program counter seems to be working, and it was comparing with the value of 45. So far so good. And yeah, by the way, it seems like we've just ended the STX instruction. So yeah, I will first dump this to the unit test, and then we'll go and implement the STY, and there we'll stop for this session at very least. Okay, okay, so one more time. Absolute addressing, the new opcode. So from the X register it goes to the memory, wasn't here before. Nothing but the program counter has changed. Yeah, this seems to be just fine. So let's grab the tests. And this is gonna be STX. And just to provide a placeholder for STY as well. Okay. Okay. Yeah. So we can keep on going. So yeah, I think I still can reuse. I'm sorry guys for copy pasting back and forth. This might seem a bit weird, but it just stays in my head after I'm doing so. Okay, so now I want to move this to the Y register, and this is going to be STY to 0 page. Okay, so register Y store 45, and now I need the opcode. So 84, remember 84, 84, okay, now it should give me an error that the opcode is not supported, which is correct. And now let's go to the execute. Okay, so compare AL with this STY 0 page. So is this the STY 0 page addressing mode? If so, jump equals to STY 0 page. Execute it. Okay, so I'm gonna be using the STA 0 page again as the template. STA 0 page, this one, copy. So here is the STX 0 page, which goes after LDX 0 page, and after the LDY 0 page. I think it's the right place to put this. STY 0 page addressing mode, STY, and we want to put from the register Y. So this should make the trick. Let's have a look. Okay, so we get the value of 45 in the Y register, and we store it to the 0 page 4, 0, 1, 2, 3, 4. We get this value of 45. So the program counter gets increased by 2, which is correct. And yeah, the test cases are working exactly the same way because we didn't change. So yeah, so the value is the same. It's just previously we did put the value from A register, from X register. Now we do this from Y register, but all of the time it gets to 0 page 4. So yeah, that's why the test case is still kind of working. So far so good. Okay. Yeah. Okay, so now let's reuse the second test, but in this case, instead of using the Y as an offset, we're going to be using the X as an offset. Paste. So I want to load the value of 38 to the Y register. So set Y register to 38 and X to 1. So set register X to 1. Now this would be STY 0 page plus the X offset. Now let's grab the opcode. So 94, remember 94. 94 94. Let's have a look. It should say that opcode is not supported, which is not by the time at this moment. So 9404, we still have this value, so we're gonna be right into the next one, which is okay. So yeah, now let's go and execute and implement it, right? So here, comparing AL, the current opcode with instruction STY 0 page X offset. So is this STY 0 page plus Y offset opcode? Not the mode, but opcode. Jump equals to STY 0 page X. If so, then execute it. So this time I'm going to be using this STX 0 page Y as a template. So let's search that STX 0 page Y. And I'm going to put this after LDY 0 page X. LDY 0 page X. So just right after this one. So I have STY 0 page plus X offset. Here I have STY 0 page X. All the same. Yeah, I need to change the commentary some there. So this. Yeah, these commentaries are messed up already. Yeah, this should actually work. Yeah, and it does, so I just need to fix the commentaries, really. Yeah, I forgot to fix the commentaries. So we got the value of 38 to be stored to the memory. So 0 page 4 plus 1 plus offset 1 that is stored in the X register, and we have 0.5, and here we have our value, and the tests are fine, but I need to change, so store the value of X, so this matches for some reason. Yeah, here Y in BL, and here Y, and here X, and the STA 0 page X and A, and yeah, and as far as I've been using this one as a template, so the commentaries here is still just fine. Okay guys, so it seems like it's pretty much all about it, I believe, hopefully. So yeah, STY, okay, so I gotta run label, and probably gotta run labels for X as well. Yeah, I didn't see this, guys, at all. Okay, let's go and fix this. Labels doesn't matter that much, really, but so for accuracy, this might be on the cards. So this is gonna be test 0 page Y. Oh no, we still have the absolute address, and okay, so 0 page Y. Yeah. And for this one, we had just the 0 page. Yeah, which is correct. So in the unit tests for the previous, so this was absolute, and this was 0 page X, which was correct, by the way. Yeah, and this is just the 0 page. Yeah, those should be fine so far. Yeah, and the very last test is the absolute, so STY absolute addressing mode. So yeah, probably I reuse the STX. So the label should still be correct. Copy. And one last task, guys. One last unit test. And we are done with the set instructions. I really hope this is gonna be working. Yeah, that would be really cool if it does work eventually. This is gonna be very cool in that case. So to the Y register, we want to set the value of 45. This is gonna be STY. Okay, little Indian. Okay. So now let's grab the opcode. 8C. So remember 8C. I'm going to test 003. Okay. 8C. And now it should say that no such opcode, which is okay. And now let's go to execute. And down below here, compare AL with STY absolute. So is this the STY absolute address and mode opcode? And if so, then jump equals to STY ABS. Okay. So which one would I use? Probably I can use STX ABS. So let's search for STX ABS. And I want to put this just right after LDX ABS. So after LDY ABS. I want to put it here. Okay, so this is going to be STY absolute addressing mode. So this is going to be STY. This is going to be Y. This is going to be Y. And here is going to be Y. X, sorry. Just fix the commentaries from the previous part. Okay. Yeah, it would be a good idea to walk through all the commentaries when I end up with this sort of thing. It takes ages, but might be making sense. Okay, so let's try to run, and we got it. So we got the value of 45 being stored at the absolute memory address of 0104, 0100, 1, 2, 3, 4, and we get this value of 45. And at this particular place, I think we can stop because yeah, all the instructions seem to be implemented. So yeah, only 3 tests for as per STX and STY. Yeah, this is pretty much all about it. Yeah, I'm pretty satisfied at this point, guys, and this is really cool. So I would say that we have implemented the most significant instructions and yeah, the most difficult ones, I believe, because for all of this, like say logical operators, we just reuse the routines to for getting the value to LDA from all the addressing modes, because these operate only on a register. So it's really cool. By the way, let's quickly check this. So if this is really so for instance, let's say 80C, right? So affects lots of flags, but it only affects It only affects what? It only affects the A register, right? Yeah, it adds to the A register. Bitwise and the same thing. Yeah, so I'll need to learn about some of the operators. I'm not 100% sure how they're working, and then we can go and implement them as well. So yeah, just the very last look at what I have left. So stack operators. Okay. I'm just wondering why. What about TSX? Probably he considered, yeah, probably in the transfer ones. Nope. So there should be TSX. Does it ever exist actually? TSX. Yeah, it does exist, but for some reason, probably in that particular place where I grabbed the opcodes from, doesn't seem to be working really. Not implemented. That's a bit strange. Yeah, it seems like it's just simply not being implemented for some reason. Well, probably not the most useful ever opcode, but yeah. Okay. Okay. Branches. Yeah. By the way, just to make it a little bit more interesting, probably I can try to implement the input and output inspired by the Apple I computer, which I have been talking about in the previous videos. So as far as we can load and save the data and store the data to the absolute addresses, we can assign the specific memory address to read from keyboard, like to store the value of like the very last ASCII character read from keyboard, and also another memory location just to echo the character that we want to type. I think that's something that we can already do, and I'm just wondering, so say this logical operation, so and or, is this X or what does this E or stands for? I'm not sure. Well, we can use bit for memory, 0 page and absolute address in most. This is cool. I didn't know about this. Okay. Transfer registers. Yeah, I will need to add one more TXS to the stack operations. TSX, not TXS, but TSX. So transferring the stack pointer to the X register. Okay guys, so yeah, I just really need to wrap my mind around this and in order to figure out how to proceed. So this is it from my side. Thanks for watching, thanks for following this series. Yeah, until the next time, and take care.